Hello students, welcome back to a new mathematics program for grade 9. Today we are going to talk about trigonometry. Well, this is the second part of a series of 3 videos based on this chapter. Remember that in the first part we talked about the definition of trigonometry. We have seen some real-life examples where we can use trigonometry. We have revisited the Pythagoras theorem, and then you were introduced to trigonometric ratios. In this second part, we are going to talk more about trigonometric ratios. Students, in this program, you're going to learn more about trigonometric ratios. Then you're going to learn how to use trigonometric ratios to find unknown sides and unknown angles. So let's begin with a recap of whatever you have already learned in the first part of this chapter. In the first part, we talk about a right angle triangle, the longest side, which is called the hypotenuse. If we have an angle x inside the triangle, then the side which touches the angle x is called the adjacent side, and the side which is opposite to the angle x is called the opposite side. Then you are introduced to the 3 trigonometric ratios, namely sine x equal to opposite over hypotenuse, cos x equal to adjacent over hypotenuse, and tan x equal to opposite over adjacent. We also talk about a scientific calculator. However, electronic calculator is not allowed in the examination at grade 9 level. So, for questions based on trigonometry, the values of trigonometric ratios will be given to you. Now, let's have a look how we can use trigonometric ratios to calculate unknown sides. In the following triangle, you are asked to calculate the length of the side AB, given that cos of 30 degrees equal to 0.866, sine of 30 degrees equal to 0.5, and tan of 30 degrees equal to 0.57. You are given with these values of trigonometric ratios because an electronic calculator is not allowed in the examination at grade 9 level. Now, in this triangle, the length of AC is given as 10 centimeters. You are asked to calculate the length of AB. So first, we are going to analyze this triangle. We're going to write the given side, which is here the hypotenuse. Then you are asked to calculate AB. The length of AB is called the opposite of the angle 30 degrees. So analyzing these 2 given factors, the opposite side and the hypotenuse, we are going to decide which trigonometric ratio we are going to use to obtain the length of AB. Remembering the acronym SOHCAHTOA, you will notice that we are going to use the trigonometric ratio sine. So we can write in this triangle, the hypotenuse is given and the opposite side is to be calculated, so the ratio sine is used. Sine of 30 degrees equal to opposite over hypotenuse, as seen in the acronym SOHCAHTOA. SOH stands for sine equal to opposite over hypotenuse. The value of sine of 30 degrees is given as 0.5. So we write 0.5 equal to AB. AB is the opposite side, and the length of AC, that is the hypotenuse, is 10. To obtain AB, you're going to multiply both sides by 10 to eliminate the denominator on the right-hand side. So we have AB equal to 0.5 times 10, which is of course equal to 5 centimeters. Let's have a look at a second example where we are going to use trigonometric ratios to find an unknown side. In this triangle ABC, you are asked to calculate the length of the side AB. You are given with AC equal to 100 millimeters. Again, we are going to analyze this triangle. We are going to write the given side and the side which you need to calculate. Here, it is the side AB, which is the adjacent side of 40 degrees. Remembering the acronym SOHCAHTOA, you will notice that for this question, you are going to use cos, that is CAH, which stands for adjacent over hypotenuse. In this triangle, the hypotenuse is given and the adjacent is to be calculated. The ratio cos is used. Cos equal to adjacent over hypotenuse. Replacing the given value of cos of 40 degrees, which is 0.77, it is equal to AB over 100. To eliminate the denominator on the right-hand side, we multiply both sides by 100. Hence, we can obtain AB as 0.77 times 100, which is, of course, equal to 77 millimeters. A third example, where we are going to use trigonometric ratios to find an unknown side. In this triangle ABC, AB is 5 centimeters, the given angle is 35 degrees, you are asked to find the length of BC. Remembering the acronym and labeling the given side and the side which you need to calculate, you will notice that for this question, you are going to use the trigonometric ratio tan. According to this acronym, SOHCAHTOA, you are going to use TOA, T-O-A, which stands for tan equal to opposite over adjacent. Now, we are going to replace the given value, that is tan of 35 degrees, which is 0.7. The length of BC is to be calculated, and the adjacent is 5 centimeters. Here we are going to multiply both sides by 5 in order to eliminate the denominator on the right-hand side. So 0.7 times 5 equal to BC over 5 times 5 on the right-hand side, where the 5 will get cancelled. We will be left with BC equal to 0.7 times 5, which is, of course, equal to 3.5 centimeters. A fourth example. In this triangle PQR, you are asked to find the length of PR, that is the hypotenuse. The given side is the opposite of 30 degrees, which is 5 centimeters. According to the acronym SOHCAHTOA, you will notice that we are going to use the trigonometric ratio sine, which is equal to opposite over hypotenuse. Now, when we replace the given values, we will have 0.5 is equal to 5 over PR. In this question, the hypotenuse is unknown. So to obtain the value of PR, first we are going to multiply both sides by PR to eliminate the denominator on the right-hand side. You will be left with 0.5 times PR equal to 5. Now, to obtain PR, we are going to multiply both sides by 1 over 0.5. That is the multiplicative inverse of 0.5. So, when multiplying by 1 over 0.5 on both sides, the 0.5 will get cancelled on the left-hand side, and you will be left with PR is equal to 5 times 1 over 0.5, which is equal to 5 divided by 0.5 equal to 10 centimeters. Dear students, now I'm going to show to you how to find angles in a right angle triangle using trigonometric ratios. In this first example, you are asked to calculate the angle X using as much information given as necessary. So in this triangle, you are asked to find the value of the angle X. You are given that the hypotenuse is 13 centimeters, the adjacent is 12 centimeters, and the opposite is 5 centimeters. you are also given with these trigonometric ratios. That is, cos of 22.6 degrees equal to 12 over 13, sine of 67.4 degrees equal to 12 over 13, and tan of 21 degrees equal to 5 over 13. Now, to be able to find the value of angle x, first we are going to label the different sides of the right angle triangle. This is the opposite side. 13 is the hypotenuse because it is the side which is opposite to the 90 degrees. And the 12 centimeters is the adjacent side because it touches the angle x. Now we are going to write the trigonometric ratios for this triangle, starting with cos of angle x, which is equal to adjacent over hypotenuse. Here it is 12 over 13. Then sine of angle x equal to opposite over hypotenuse equal to 5 over 13. Then tan of angle x equal to opposite over adjacent. Here it is 5 over 12. Now we are going to compare whatever we have calculated as trigonometric ratio and whatever is given in this question. When comparing the given values and the calculated values, you will notice that cos of 22.6 degrees equal to 12 over 13 and cos x equal to 12 over 13. So we conclude that the angle x equal to 22.6 degrees. Let's have a look at another example where we are going to use trigonometric ratios to calculate the angle x. In this diagram, the required angle is x. The given sides are 12, 9.7 and 7 centimeters. The given information is cos of 43.8 degrees equal to 70 over 97, sine of 53.9 degrees equal to 97 over 120, and tan of 35.8 degrees equal to 70 over 97. First, we are going to label the different sides of this right angle triangle. The hypotenuse, which is opposite the 90 degrees, the opposite side, which is the side opposite to the angle x, and the adjacent side, which is the side which touches the angle x. Now we are going to write the trigonometric ratios for this triangle, starting with cos. Cos of angle x equal to adjacent over hypotenuse equal to 7 over 12. Sine of angle x equal to opposite over hypotenuse equal to 9.7 over 12, which is same as 97 over 120. Then tan of angle x equal to opposite over adjacent equal to 9.7 over 7, which is same as 97 over 70. Now we are going to compare the given information and the values of the trigonometric ratios that we have calculated. When comparing these two values, we will notice that sine of 53.9 degrees equal to 97 over 120, and here sine of x equal to 97 over 120. So we conclude that angle x equal to 53.9 degrees. Students, now I'm going to give you some exercises for practice. In the first exercise, you're going to calculate the side AB in the following triangle. In this triangle, the angle that you're going to use is 35 degrees, so values of sine of 35 degrees, cos of 35 degrees, and tan of 35 degrees are given to you. Remember that you are not allowed to use an electronic calculator. For the second exercise, you're going to calculate the side PQ. You're going to use 50 degrees for this triangle, so the values of sine of 50 degrees, cos of 50 degrees, and tan of 50 degrees are given to you. Third exercise, calculate the side OM. In this triangle M and O, values of sine cos, and tan of 45 degrees are given to you. Remember that you are not allowed to use an electronic calculator for these exercises. In the fourth exercise, calculate the length of side AB. Here, values of sine, cos, and tan of 70 degrees are given to you. Fifth exercise, you are going to calculate the angle X. Here, cos of 36.9 degrees, sine of 53.1 degrees, and tan of 36.9 degrees are given to you. You're going to use as much information as necessary for the fifth and sixth exercise, where in the sixth exercise, you're going to calculate the angle PQR. Students, in this program, we learned about trigonometric ratios. Then we have learned how to use trigonometric ratios to find unknown sides and unknown angles. If you want to have more information on this chapter, here are some links. Students, this program ends here. We have talked about the chapter trigonometry. Remember that this program is the second part of a series of 3 videos based on this chapter. So see you soon for the third and final part of this chapter. Till then, goodbye.